Hello. So in yesterday's video, we looked at completing the square, which is a topic you would have seen in GCSE maths. So completing the square is just where we want to rewrite a quadratic. So for example, this ax squared plus bx plus c, and we want to rewrite it in this form where we basically put a linear factor here and we square that linear factor and we get a result like this. So we basically completed the square with a general quadratic in this form. And something I didn't mention yesterday is that obviously we assume A and B and C are non-zero numbers for this to work. So yeah, we got this result when we completed the square. So we completed the square with this quadratic. We got this result. That's what happens when you complete the square. So let's say we want to actually solve the equation ax squared plus bx plus c equals 0. How would we solve this equation? By using completing the square. So what we can just do is just set this equal to 0 because obviously this expression is exactly the same as this expression. And then we can proceed to just make x subject to the formula. So we can divide everything by a because a is a non-zero number, so we're allowed to do that. So we can divide everything by a, we get x plus b over 2a all squared, and then plus this number divided by a. So if you divide this fraction by a, you get 4a squared. Because yes, when you divide a fraction, you keep change, flip essentially, keep that first fraction, times by 1 over a, you get an extra a in the denominator there, hence the 4a squared. And this equals 0. Okay, great. I'm just going to make the writing a little bit smaller. So then, okay, if we take away this this term here from both sides, we get x plus b over 2a all squared is equal to the negative of this fraction here. But if you take the negative of this 4ac minus b squared over the 4a squared, you actually just get b squared minus 4ac over 4a squared. Okay, so we get that. So now what should we do here? Well, let's square root both sides to get rid of this square operation here. And obviously we've got to be a little bit careful because x can be any real value. So when we do take the square root, we've got to take the positive and the negative square root. So x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. I'm probably going to keep this all on the same page. Let me just make the writing smaller. Okay, so we get that. So now then, if we square root, I mean, we can't really simplify this numerator. We just have to keep the numerator as it is. So b squared minus 4ac. If we simplify this denominator, let me just try and emphasize that this square root is covering the denominator as well. So square root of 4a squared, well, that's just 2a. This is 2a in the bottom. And so x plus b over 2a is equal to the square root of b squared minus 4ac over 2a, well, plus or minus that fraction. Then we can just subtract the b over 2a from both sides. So we get b over 2a, sorry, minus b over 2a, plus or minus b squared minus 4ac under the square root, all divided by 2a. And so therefore, we've got a common denominator. So we just put this under these two fractions under one common denominator. So therefore, we get x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And you'll probably notice this. This is the quadratic formula. So this is one way in which you can prove the quadratic formula by using yesterday's video and completing the square, and then setting this equal to 0, making x a subject to the formula, and you get the quadratic formula. Quadratic formula there. So it's just important to know how you actually derive this formula, just so you can actually see that you do use completing the square, this completing the square technique, to get this quadratic equation formula. And it's good practice, again, just with completing the square, because you may have to complete the square with examples such as 2x squared minus 4x plus 7. So, I mean, you could just like memorize this formula up there. Obviously, the a would be 2 in this case, the b would be minus 4 in this case, the c would be plus 7 in this case. So you could just memorize the formula and plug the numbers into this formula, or you can just use the process we used in yesterday's video to actually derive this yourself. So yeah, that's just a summary of how we can actually prove the quadratic formula by using completing the square.